Hi everyone, this is lesson 3.6, Factoring Polynomials. Factoring polynomials is finding all the divisors of a polynomial. It is similar to finding the prime factor of a number. It can be easily done by a combination of the factor theorem and use synthetic or long division, in which we have already talked about in the last lecture. The remainder theorem describes the relationship between the divisor, dividend, and quotient in order to find the remainder without doing the division. So this method allows us to find the remainder in a very short and effective way without having to do the long method that we have talked about in the last lecture. Now let's take a look at example 1 from your learning resources. It asks us to find the remainder when x cubed plus x squared plus 2x plus 1 is divided by x plus 1. Here's a useful equation that you should memorize. F of x, which is the original equation, is equal to the divisor times the quotient plus the remainder. Note that if the function is divisible by x plus 1, then there will be no remainder. Let f of x equals to the remainder, and let x equals to negative 1, because we want x plus 1 to be equal to 0. So we plug x equal to negative 1 back into the original equation. We solve it, and we will get f of negative 1 equals to negative 1. Therefore, the remainder is negative 1. It's a much simpler method that will save you a lot of time, instead of doing it like the method we have in the last lecture. Now let's look at example 2 from the learning resources. It asks us to determine the quotient of 4x cubed minus 2x squared minus x plus 1 by 2x plus 1. Once again, f of x equals to the remainder. Let x equal to negative 1 over 2. We plug x is equal to negative 1 over 2 back into the original equation, and we solve for f of negative 1 over 2. The answer will be 3 over 2, and since we said f of x equals to the remainder will also be 3 over 2, and thus the remainder will be 3 over 2. The factor theorem is a special case of the remainder theorem. When the remainder is 1, it means that the divisor is a factor of the quotient. Now let's look at example 3 from the learning resources. Is x plus 1 a factor of the equation x cubed plus x squared plus x plus 1? Well, if the remainder is 0, then it will be a factor. So once again, let x equal to negative 1 and plug x equal to negative 1 back into the original equation. And we get that f of x is equal to 0. Therefore, yes, x plus 1 is a factor of the original equation. Now let's take a look at example 4. It asks us to determine the value of k in the polynomial 12x cubed plus kx squared minus x minus 6 with a factor of 2x minus 1. So once again, we settle what our x is. So this time x equals to 1 over 2. And once again, we write our original equation and we plug x is equal to 1 over 2 into the original equation. We have to make f of x equal to 0 because we want the remainder to equal to 0. And then we solve for k. And we end up with k is equal to 20. Therefore, when k is equal to 20, 2x minus 1 will be a factor of the original equation. This is the end of this lecture. Please remember to do your activities as well as your assignments, and I'll see you guys next lecture.